I wanted to start off by first thanking co-organizers of the ReactNYC. Let's give them a little round of applause. Always interesting programming, stuff to learn, so great things happening there. Also, thank you Spotify for hosting the event. It's pretty sweet to have a space like this to give a talk at. Right, so my talk today is going to center around creating audio applications in React. So I came up with this really cheesy name, Reacting to Audio, which is pretty fun. So essentially I want to talk about building applications for processing audio. So the main goals of this talk are, 1, to provide an introduction to the WebAudioAPI, 2, to inspire you guys to create audio applications, and 3, hopefully teach you a little bit about audio routing, sound effects, synthesis, things like that. The main reason for number 2 is actually Spotify is hosting a music hackathon on Saturday, so I will be there. Would love to see some familiar faces. It should be a fun time. So essentially, I want to teach you guys how to do more than just play sounds on the front end, right? Because we all know that the HTML5 audio element exists, right? But this is just kind of boring. It's not that interesting. You can play and pause, you can change the volume, but we want to do more interesting stuff, right? So in order to do that, we need to know how the WebAudioAPI works. Well, what is the WebAudioAPI? According to Mozilla, on their docs, it's a powerful and versatile system for controlling audio on the web, allowing developers to choose audio sources, add effects to audio, create audio visualizations, apply spatial effects such as panning, and much more. So it's a little bit of a loaded description, but we're going to kind of go into each of those things on down the road. So how does it work? There's 3 kind of main components to this, right? They're building blocks that kind of build up on top of each other. So the audio context you can think of as like a space itself, right? So in the real world, we would have like a studio or a room, right? And so that kind of houses all the audio elements, effects, things of that nature. And then we have audio nodes that would be inside the room. So another real world analogy, you can think like a guitar or a delay pedal, right? These are all audio nodes that will either be the sources of sound or will add effects to the sound. And then we have audio parameters, which are parameters for each of those nodes. So you can think of like the tuning for a guitar, or the delay time, or this just got louder, which was weird. The volume, things like that, right? So in a simple example, you have the context, which is again kind of like the room. Input could be a guitar. Effects, that'd be another audio node, and then you have parameters for each of those things: the tuning, the playback, the volume, delay amount, etc. And then those things are plugged into the destination. And the destination is kind of just like a hard-coded value as like the output from your browser. So anytime you're interacting with the WebAudioAPI and you want the source to be heard, you plug that into, it's called context.destination. So here's a really simple example, right? First, what we're doing is we're creating an audio context. We're grabbing a song, and now this can be either a hosted file, or it can be a song that's, or a MP3 file, WAV file that's bundled in your Webpack. What you're going to do is you're going to fetch the song, you turn it into an array buffer, you turn that array buffer to an audio buffer through the function decode audio data, and then you're going to create a buffer source. So this is going to be a source for the sound. You assign that audio buffer to the source, you connect the source to the destination, and then you start it. And I know what you guys are thinking at this point, like, that just seems really confusing. And you're totally right until you want to do some audio processing, right? So let's talk about some effects. Let's say we wanted to add a filter on top of it, right? Normally would be impossible, but thanks to the WebAudioAPI, again, we're doing the same thing, just fetching the song, but what we're doing is we're creating a filter using a function createByQuadFilter. The filter type in this instance is going to be a low-pass filter. However, there's other options in terms of a high-pass, band-pass, notch filter. Then you're setting the frequency for it. And then what you do is you connect the source to the filter, and then the filter to that destination. So if you guys think back to that like diagram that we saw earlier, you have the input source plugged into an effect, plugged into the destination. And so it's a pretty straightforward routing structure. So let's look at another effect, right? And so in this instance, we have a thing called a convolution reverb. And so this is where I'm going to delve into a little bit of that third thing that I was talking about, where you guys can learn about music and effects. So someone created this thing called a convolution reverb, or what you can do is take an impulse recording. An impulse recording is a recording of a sound within a space, right? So if I clap my hands in this room compared to the Sistine Chapel, it's going to be a very different type of sound. And so what you do is you take that short recording and you plug it into a convolution reverb, and it does some really crazy math, and then it allows you to add that reverb to any other sounds that you are routing through it, right? So it's kind of fun and interesting. I'm going to play the impulse response that I pulled for this project right now, right? So if you heard that, it's just kind of like a clap in what might be like a really damp and dreary warehouse somewhere, right? Let's just assume it was in Detroit or something. Let's see if I can do this. Right, so if we play a sound source, right now we're hearing that sound then routed through that convolution reverb that was created through that impulse response. So this is the dry sound, this is the reverb sound. By the way, if anyone can name any of these tracks, I'll buy you guys a beer later. Let me go back. So again, here's kind of how you would get the convolution reverb to work. If I can find my mouse. What you're doing is you are creating the source, plugging the source into the convolution reverb, the convolution reverb into the destination. The only thing that really changed here is you are then setting the buffer of the convolution reverb to the reverb buffer source. So if you noticed when I was playing around with the little dial thing, we were dragging it from a completely dry sound to a completely reverbed sound. And so this is a little routing diagram that shows how I kind of did that. And so what happened is you're taking the source and you're plugging it into two different things. One, you're plugging it into a gain node. The other one, you're plugging into a reverb. That reverb goes into another gain node, and then both of those gain nodes go to the destination. And so what happens is when I'm dragging the dial back and forth, what I'm actually doing is I'm changing the volume on both of those gain nodes. So when I hit halfway, both are playing at halfway, and then when I'm going to one side, it's either all the way on or all the way off. And so as I was building this thing, I was like, hey, this is cool and fun. Why don't I try and build a little DJ booth with it? As you guys know, DJ booth consists of two turntables and a mixer. A routing diagram for a DJ booth would look something like this. You have two turntables that are the audio sources, and then you have those plugged into gain nodes that are on the mixer. And you have individual volume control for each of those things. And then those go into a crossfader. And so again, you're controlling the volume by either going to A or B or somewhere in between. Those go to a master gain node, and then those go to a destination. And so if we go over to here, right? On one side, we have some audio that's playing. We can control the speed of things. So here, actually, I'll stop it, right? We can make this thing play slower, make it play faster, somewhere in between. So if we went all the way over on the A side, we can control the general volume for that. But then what we can do is we can start fading into. Terrible mixing, I know, but you kind of get what's going on, right? So it's a fun little thing that you can do with this. Let me go back to the routing diagram. So at this point, we've kind of looked at audio sources. We've looked at adding effects. We've looked at routing. We've looked at applying spatial effects. So spatial effects being that reverb that we were playing with earlier. The thing that we haven't touched on yet is the analyzer, or creating audio visualizations. So the way to do that is with an analyzer node. So you can think of an analyzer node being like any of these other effects where you're just routing audio to it. However, it provides output of the signal source that is being passed through it. So there's kind of two main functions that you can do with it. You either get data for the signal itself, so like kind of what the waveform looks like, or you would get some sort of like frequency graph that would represent where in like the auditory spectrum the sound is being created. So before we get into what that looks like, here's kind of just like a little bit of code. This is for creating a stream that's coming from your internal microphone. And so here we're using navigator.getUserMedia. We're creating a stream, and then kind of down in the lower part, we're creating an input point where we use create gain. We create a media stream source. Again, this is WebAudioAPI, so creating a stream source. We're plugging it into the input point, and then we are plugging that into an analyzer node. And so down at the bottom, there's essentially two examples of how you would get the data out of it. So one is a frequency graph, or what you would use for a frequency graph, and the other is for a signal. So there's get byte frequency data and get byte time domain data. And again, those are essentially representing the waveform that's being passed through, or the graph itself. And so now I need my two volunteers to come over here to help me out with some stuff. So if we scroll down a little bit further, all right, come over here. You're the Hummer, so get kind of close to the computer. Here, actually, just stand over here. And so what we're going to do, so a little explanation of what's going on here. Anyone who's familiar with like sampler pads or like MPC pads, kind of creating like a crappy version of an MPC pad. But what we're going to do is we're going to click one of the pads, and that's going to start creating a recording, and then we're going to be able to see data through the analyzer node of either the signal itself or the frequency. And so first we're going to start off with the signal that's coming through. So if I can get you close, and then you want to just hum something so that we can kind of see what that looks like on the screen. Love it. So here, we could even click it and listen to it again because it was so awesome. Ooh, dude, you got some soul, huh? And then if you want to come over here and do some whistling for me. So here, I'm going to toggle the visualizer, and so we're going to change it into a frequency graph. So if you want to, I saw you were doing whistling like this before. If you want to whistle like a normal person, which would be cool, like go up and down a little bit in frequency, do that for us. Get even closer. Okay. It's not totally working well, but well, there we go. So you can see what's happening, right? Like you have the frequency spatial data dancing around, all fun and stuff. So thank you. Thank you, volunteers. Let's give them a round of applause, huh? So back to this. So needless to say, I've spent way too much time playing with this stuff. And it's now at this point where I want to impart some words of wisdom because I've felt a lot of pain building with this stuff. And also, this is a React meetup, and we haven't really talked about any React stuff at this point. Any of the audio projects that I've built previously have all been with React. So it's a good combination of the two. I would highly suggest using React when you're building some of this stuff. Okay, let me just stop talking, or actually I need to keep talking. So one of the issues is once a source is stopped, it actually gets destroyed. It's a little thing I found out the hard way, smashing my computer, wondering why it wasn't working. So a little hint, if you guys remember, when we were fetching a sound, we were turning it into an array buffer, and then we were turning it into an audio buffer. A smart little tip that I learned would be storing that audio buffer into this dot state, or storing it somewhere in like the React Redux store so that you can quickly access it later. Because when you need to create a lot of stuff on the fly, it'll make the process a lot smoother and faster, and it'll cut down on latency when you can just grab it from memory real quick and create another source, as opposed to fetching it from somewhere, going through all that processing in order to do it. Second thing is routing can't and shouldn't be handled by a single component, especially if you're building with React products, because you essentially need to pass these audio nodes around in order to connect them to each other. So if you guys remember that DJ booth thing that I was doing a little while back, essentially what I have to do is when I initialize the mixer itself, because the routing doesn't change on the mixer, I have to pass those gain nodes back into a parent component, and then when I'm creating the sources for the songs on the fly, once I hit play, I then use the parent component again to plug those sources into the gain nodes. And also this code, I'll show you guys the repo later. It's up on a GitHub repository, so you guys can kind of grab it, play around with it, see how I did some of this stuff in order to figure it out. And so at this point, we've talked about a lot of the functionality of the WebAudioAPI, but what about synthesis? I guess that was supposed to be a question, and the answer is you can. And so it kind of, the WebAudioAPI provides with really like baseline functionality to create oscillators. So an oscillator is just a sound source that has like a constant frequency value. I mean, you could change it, but it provides you with some basic waveforms as the types of oscillators. So if you guys are familiar, you have sine waves, triangle waves, square waves, sawtooth waves, and they behave, again, because they're an audio node, they behave very much like all the other audio nodes we were looking at. So we can create an oscillator, we connect it to context.destination, we can start, and then we can play frequencies on the scale. And so you can, but you shouldn't. And I know what you're thinking, wait, why? Because if you try to build anything of significance, this is going to happen. Your face melts, not in a good way. So for instance, a very baseline functionality for all you nerds out there who play with synthesizers is envelopes, where you have attack, decay, sustain, release. And so for you nerds who are non-nerds, what this essentially means is it controls how the sound behaves over time. And so you essentially, when you hit a note, you want it to like slowly fade in and then like fade out a little bit until the note is held at this level. And then once you release it, it drops off a certain way. If you had to build this with just the WebAudioAPI, you would need to do something like have some sort of interval that's running all the time and changing the gain node, the volumes of it until the key is released, and then you do it. So don't do it. My suggestion: use Tone.js. Tone.js is a fantastic web audio API, or no, sorry, a JavaScript library that's built on top of the web audio API. And so it's awesome because it has a lot of this really baseline functionality already kind of built out for you. So for instance, if we wanted to create a simple synthesizer, all we have to do is say new tone synth. And we assign the oscillator type, we set up the envelope, we could even change the type later on. We could set the frequency to 200, and then here, they use a little bit of like a different syntax, or instead of saying, connect to context.destination, you say synth to master, and that's like the master output. And then you could say synth trigger attack at a certain frequency for a certain period of time. So again, the functionality is on it. It is awesome. It takes care of a lot of the baseline stuff for you. It even has timeline functionality, right? So there's this thing called the transport, which is essentially, like if you're trying to build a digital audio workstation, it'll keep track of the time of things. So you could even do things like loop the timeline for one measure, and then you can put events on that timeline, and because the timeline is just looping itself, it's going to play those things over and over, right? So I also have a kind of version of that happening right now. So if anyone's familiar with audio production, there's these things called sequencers. So essentially what's happening is we set up a loop, it's 1 bar long, and there's steps on this bar, right? And so in case you couldn't tell, this is essentially like mimicking a keyboard. So you have the white and black keys. And so what we could do is we could put notes on this thing. And then we could even change the octave that these things are playing at. So you guys kind of get what's going on there, right? Again, this code is going to be on the repo that I push up, so you can play around with it and see what's happening. I'm going to restart it so we don't have to listen to that all the time. I guess at this point, I was also going to show you guys another project that I built at one point. Let me see if I can find it. So again, going back to Tone.js, providing a lot of like the baseline functionality and providing routing for you. This is kind of like a pseudo modular synthesizer that I constructed at one point. And so essentially it gives you each of the individual components and allows you to route them dynamically, right? So what happens is we have just an oscillator going right here. So you can imagine that we plug the oscillator into the master output, and what that's doing is that's creating this tone, right? We can visualize it there. If we change the frequency of it, this sort of stuff happens, right? And so what happens is it can get to really complicated routing structures where you are, let's say we're plugging this thing into a filter. The filter is then going to be playing it out. We can change the frequency of the filter so we can actually see the sound change. This thing has capabilities for like a MIDI device, right? Right now I don't have a MIDI device, but let's just use like an analog keyboard. We're going to plug that into the envelope. We're going to set that up in here. Sorry, I actually have to do this real quick. Plug this into here. This thing into here. And we're going to plug the CV out into this. So then I'd be able to play my keyboard like a little synthesizer. So I mean, it provides you with a lot of the building blocks. You can think of it as almost like little Legos. Like it's the same way with like React components, right? Like once you have a lot of these Lego pieces already constructed, you can then build them up in really cool ways. And so basically this thing is just providing a user interface for people to interact with audio. And that's just something that I love nerding out on and playing around with. So yeah, that's kind of what's happening. So again, back to my main goals. I was hoping to provide you guys with an introduction to the WebAudioAPI. I feel like that worked. Is anyone inspired to create audio applications? Yeah. All right, I see some hands. Love it. And hopefully you guys learned a little bit about audio routing, sound effects, blah, 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 whatever, and you weren't thinking this. That's all I got. I don't know, are we taking questions? Should we just... 2 questions. Okay, 2 questions, only 2. Oh, you got a question.
Do you make actual music with your own web tool?
No, not yet. Maybe soon. I don't know. So the modular synthesizer thing we were just looking at, I want to create like a recording functionality to it, so you could record whatever sound is being created in there and then use it for other things. But I do actually have a background in audio engineering, so that's why I kind of get some of this stuff.
Can this work in React Native as well?
And unfortunately, no. The WebAudioAPI actually might work in React Native. However, at this point, Tone.js does not work on mobile systems just because it's a little bit heavy in processing power, and so it just won't work. So, cool. Thanks, you guys.